Capitoline is an independent data center consultant. We offer training, which is what this webinar is about, but we also audit existing data centers in different locations around the world from an infrastructure perspective and from an operational management perspective in terms of processes and procedures and physical infrastructure. We also assist in the design and technical supervision of new project builds, and we assist clients in improving the operation of their data center, looking at processes and procedures. Let me start by talking about what essentially what a data center is. A data center provides a safe place to locate your computer equipment, storage, and communications devices. So it's primarily an IT facility. However, we must have enough power to maintain those devices, so we must have the correct power infrastructure and the correct power capacity. And because we have a lot of devices using a lot of power, they generate a lot of heat, and therefore we must also have a temperature-controlled environment. And along with that, we've got to provide enough connectivity to those devices, both within the data center and external to the data center. And the priority is reliability, security, and efficiency. But when we design it, we need to make it simple, flexible, and scalable. There are different types of data center. So classically, we might imagine a company that has their own computer room and support areas, and that would be what we would refer to as an enterprise data center. But we also have companies that build data center facilities in order to offer space for companies to rent to house their own IT equipment, and that's what we refer to as co-location. And there are many types of co-location facility. Infrastructure only, where there is just the space and the power and the cooling and other support facilities provided, and the client puts their own IT equipment in. But we also have infrastructure and managed services, of which there are a number of different permutations, where additional services are provided to the client, going right through to the situation where the client is just using software, software as a service, so they have no involvement in the management of the facility or the IT equipment. They are just using the IT software. And thirdly, we have another facility which is similar to these, which is a telecoms facility. And that's the type of facility that will be operated by a main telecoms provider or a mobile phone operator. It has similar requirements, but the type of equipment installed in it historically has been of a different configuration with slightly different requirements to that of our modern IT equipment. But in any of these circumstances, there are two main concerns of the operator. Those are to maintain the availability of these services, and secondly, to minimize the energy consumption in order to reduce costs. In terms of availability, there are various standards, international standards, which define different levels of availability, and typically they define 4 levels of availability. The American standard for data centers, the TIA 942, calls them ratings. The BICSI American standard and the new European 5600 standard calls them classes. And you may also have come across the Uptime Institute, which calls them tiers. The engineering philosophy in each case is very similar, although it's not identical. And the principle is that a rating 1, class 1 or tier 1 system has enough components within the infrastructure. Predominantly we're referring to the power and the cooling infrastructure and the telecoms infrastructure. Enough components to do the job. A class 2 system has some redundancy within those components. So you may have a redundancy within the cooling systems in the room, or you may have redundancy for the UPS systems, for instance. A Tier 3 or Rating 3 system will have concurrent maintainability. Now, what we mean by that is that we can remove any of the components, any of the cable routes, piping routes if we have a cool chilled water system, and replace it without losing any of the IT facility, without having to shut down any of the IT facility. In other words, we can maintain the full power and cooling capacity that we require whilst carrying out any maintenance operation. And finally, the Tier 4 or Class 4 system is fault tolerant, so it will tolerate a single fault and automatically respond to that fault in such a way that the IT equipment will continue to operate even while that fault exists. So that's availability. The other side of it, energy consumption. Well, we're trying to provide an IT facility. We're trying to provide a facility which can run software, which does useful things for our organization. So we have IT equipment, and the IT equipment obviously uses power. In doing so, it also generates heat, and therefore we need cooling to cool it down. But they're not the only elements where power is consumed. Our electrical system also consumes power. So our lighting consumes power, and our electrical infrastructure is not 100% efficient, and that's why it gets warm or heats up when we have it operating. And the biggest component of that historically has been the UPS system. So that's shown in this graph. So it depends on the configuration of the data center, how old the data center is, whether it's using modern free cooling designs as to what percentages these will be. This graphic just gives an indication. And within the IT equipment, obviously there are different components, our servers, storage, networking systems, which use different percentages of the power consumption. And again, this will vary depending on the nature of the equipment and the nature of the installation. Of course, another thing that's important to us is cost. And when we're building a data center, you can see from this pie chart of this medium-sized project that power and cooling equipment account for a very large percentage of the overall costs of fitting out a building which is to be a data center. And in this case, they're using 60% of the cost to put in the power and cooling infrastructure. If we look at larger projects, then they tend to have greater redundancy installed to improve the availability. So the result of that is that there is generally more power equipment and more cooling equipment, and therefore the percentage of the cost of building that project that relates to power and cooling increases. So in this case, 75% of those project costs go into the power and cooling systems. So there are a number of issues there that we've discussed to do with the main drivers of data center design and indeed the things that influence data center operations. There are a lot of interrelated disciplines within that. We talk about power, cooling, the layout of a data center, the cabling, the fire systems, the security. And in order to provide a good understanding of all of these things, the physical infrastructure and the manner in which we operate data centers, Capitoline developed our data center expert training courses. Now, Capitoline actually wrote the very first data center training back in 2005. There are a number of other companies that have copied what we do. We don't believe that any of them do it better because they are training companies trying to provide data center training rather than data center consultancy companies trying to impart the knowledge that we've learned over years of working in this industry. We've trained hundreds of individuals in many different countries across the world. Our training consists of a 3-day data center design course and a 2-day data center operational management course. And for individuals who do both of those training courses, then we award our data center expert certification. Firstly, let me talk about the data center design course. The 3-day data center design course covers all of the topics that you see listed down on that content. So everything from talking about the different data center spaces, because a data center is more than just the computer room. There's the facilities that hold the cooling equipment, power equipment, telecoms facilities. We talk about raised access floors. You don't always have a raised access floor, but where you do, it's important to understand the issues associated with it. Right the way through from computer room layouts, power, cooling, earthing and bonding, fire system security, IT cabling, right the way through to data center infrastructure management and building management systems which allow us to monitor and control our facility. And the courses are based on all of the standards I discussed just a short while ago, so the American standards, the European standards, and other international standards and best practices that are documented by various bodies around the world. So we talk about all of the standards. The American standards, which include the TIA 942 and the BICSI standard, the European standards, of which the most significant one is the EN 5600 series, and we talk about international standards as well. When we talk about the American data center standard, and indeed when we talk about the other data center standards, they also refer to other standards. For instance, the American standard refers to copper and fiber cabling, the pathways and spaces for that cabling, the administration of it and documentation of the cabling, grounding and bonding for safety and for telecommunications purposes, cables outside the building, and building automation systems. And there's a number of other references which are used in order to determine the best practice for data center design and operations. The American Society of Heating, Refrigeration and Air Conditioning Engineers, for instance, is one of those bodies. And they help us to determine temperatures we should operate at within the data center and the general environment. There are other IT grounding documents, and of course the Americans have a national electrical code which determines how you should install electrical cabling. So we talk about all of these different elements. We also talk in detail about the new European data center standard. I myself am actually a member of the committee which helped to develop this standard, so I'm very well versed in what's in it. We have a general concepts document, infrastructure design document, which is what we cover within the data center design document, and there's also management and operations and ways of measuring energy efficiency, such as, you may be familiar with the term PUE. And there is a document which has a list of recommended practices for improving the efficiency of your data center. So the infrastructure design section that we focus on in the design course refers to building construction, power distribution, environmental control, so temperature and humidity, telecommunications cabling infrastructure, security systems as well. So it covers all of the key elements, and in security systems that includes fire systems as well. The other references that we refer to are ASHRAE, the American Society of Refrigeration and Air Conditioning Engineers, the Uptime Institute, the European Code of Conduct, which is a document which details best practices for improving energy efficiency, and the European Telecommunications Standard Institute documents, which refer more towards telecommunications facilities. And everybody who attends the course gets given an electronic copy of the course materials. And this is just a very quick sample of what that looks like. So on the right-hand side of the slide, you can see you get a copy of each of the slides that's presented, along with detailed notes on each of the topics that we discuss. And this is a searchable document. And we find that people who attend our courses rely on this for many years to come after the training as a go-back-to reference to look up things that they learnt during the course and to check things as they work in their daily lives within the data center. So it's a very useful reference document. So to give you a feel for some of the things that we cover and what some of the presentation material looks like, much of this is a little more animated than you'll see in these few slides, because here I'm trying to summarize, so we're just stepping straight through to give you an idea of the subjects that we cover. But we talk about data center spaces, so everything from the computer room through to the support spaces and an idea of the other items that are actually external to the building that are also important to the data center. We talk about the different ratings and classes of systems, different tiers, if you like, of the data center. And we represent that graphically and in plan layouts like this to give a good feel for the principles involved. So for instance, we're looking at power cable connectivity for a class 3 stroke class 4 data center, and you can see that within those classes you have duplicated systems as demonstrated by the red connectivity lines and the green connectivity lines here. So we have a red system and a green system, A and B, so dual power feeds into each of the 3 computer rooms that are shown in the middle. We talk about more modern ways of building, especially co-location facilities where we have modular construction, and we explain what the benefits of that are and how these different systems can be built. We focus on computer room layouts. The layout of a computer room is extremely important in order to maximize the capacity that you have for IT equipment whilst maintaining an efficient room and maintaining consistency throughout that room for power, cooling, and therefore control of the environment as well, temperature and humidity, etc. Now in this image, obviously we're showing a raised floor. You don't have to have a raised floor, and we show examples of all the different types of layouts which you can have while still maintaining the efficiency of the systems. We will talk about air conditioning from the very basics, so we explain the principles of thermodynamics and therefore why an air conditioning system needs to be in place and how it works. So what works, what doesn't work. So we talk about all the different components of an air conditioning system and the different styles of air conditioning. You just see one particular type here called a direct exchange unit, where there's one unit inside the computer room and a condenser unit external to the computer room. We explain the principles of these systems, how they work, and where they should be best located. And we talk about all the different types of cooling technology. Different types of cooling technology are more appropriate for different densities of IT equipment. And by that we mean the amount of power and therefore heat that you're generating in each rack is relevant to the type of cooling system that you use. And you'll see on the left-hand side here, we're talking about getting the heat out of the IT equipment. In the middle, we're talking about refrigerants, where they take that heat and transfer it to the outside, and then we have equipment outside which rejects that heat to the external environment. And you'll see a number of different technologies referred to here, and we discuss each of those in the course. We also talk about the recommendations for temperature, humidity within the data center, specifically the computer room. And we refer to those using these devices called psychrometric charts, and we also simplify that for you. This looks complicated, but we'll explain that and in a very simple fashion and make it clear what the limitations are of the recommended temperature and humidities that you should keep your computer room and how you go about doing that. When we talk about power, this is one of the key areas for maintaining the availability of the data center. And here you see a graphic representation of what a rating 3, tier 3, class 3 system might look like. The standards, whether they're referring to tiers, ratings or classes, do differ in terms of some of the elements of how a rating 3, tier 3, class 3 system would go together. But this is just gives you an idea of how we present some of this material. So we talk about all of the elements of the power system right the way through from the utility through to the critical load, so our IT load, and what each of these components do. We also talk about how we size those components as well in terms of the capacity that we need for our facility. So we'll talk in some detail about different types of uninterruptible power supply systems, UPSs, how they work, what their function is. And importantly, it may surprise you, but fire is a major cause of downtime within data centers. Sometimes faulty fire systems, sometimes real fires, and you can imagine the consequence of a fire in a data center is massive. So we talk about fire detection, identifying that a fire is in progress, alarm systems to warn people, and suppression systems, which are there to put out the fire. This is quite an interesting subject for most people who've not had any exposure to it previously, but we talk about all the details and recommendations for that. And we talk about security. In an IT facility, we're storing a lot of valuable data. Yes, the equipment is expensive and the facility itself costs a lot of money, but the real issue is trying to prevent individuals from stealing our data. And in the case of a data center, there are obviously going to be things like firewalls and policies as far as passwords and logging in and allocating user accounts are concerned. We're concerned here in this course with the physical security of the data center. So we'll do that. We'll talk about that from the individuals coming externally and into the data center right the way through to how we handle that within our power cooling facilities and our computer room. And of course, because this is an IT facility, there will be a lot of IT cabling. And we will discuss within the course the different types of IT cabling, what is recommended for a data center facility, and the different types of cabling design that you can have within a data center, what to avoid, and how you should implement things to best practice to make things more manageable for the future. And of course, at the end of the design, we want to build a data center, and then we want to accept that data center into service. So we will touch on specifying acceptance criteria. And as you see in this drawing here, we should be specifying acceptance criteria as soon as the design is complete, not waiting until the end of the project. We then write those acceptance criteria into the contract to the builder and then carry out the acceptance criteria tests at the end of the contract to ensure we have what we set out to get in the first place. And then we operate our data center. And when we go into operation, this is where we need to be focusing on our procedures and processes in order to maintain the availability that we set out to get in our design. And that's where our 2-day data center operational management training comes into place. The industry is now beginning to realize that just providing a highly resilient design is not good enough to maintain availability. You can design a tier 4 data center, but if you don't operate it properly, you might as well have not spent that extra money. So the DCON course covers all of the topics you see here. An introduction to data center management, accepting a new data center into service, understanding the operational information and parameters, and then we go through all of the processes and procedures that you should have in place. We talk about all of the key metrics that you should measure to see how effective they are being, right the way through from maintenance all the way through to managing costs, customers and suppliers. And it's based around this document highlighted in red here, the EN 5600-3 series management and operation. We were involved in helping to write these standards, and so some of the material that's within them comes from our input, but this standard alone doesn't give you all the information you need if you're starting from scratch to understand what should be in your processes and procedures. Our operations management course covers that. It also covers energy management efficiency and best practices in order to ensure that you are managing, minimizing energy consumption and maximizing efficiency. Again, like the data center design course, this comes with a searchable electronic copy of course materials with detailed notes that you'll be able to refer to on an ongoing basis when you get back to work, especially useful if you're planning to audit or implement new processes and procedures. So we cover everything from acceptance and testing of new works. What tests should you carry out in order to ensure that you have what you set out to get in the first place before you start installing your IT equipment and operating the site. Understanding the key operational parameters such as the return air set points, humidity set points. If you have redundant equipment, should the redundant equipment be left turned on or off? Sometimes, depending on the type of equipment, it can be more efficient to do it one way rather than the other. We talk about why data centers fail, and we provide you information from our own research as to why that is. And of course, if we understand why data centers fail, then we can learn to deal with them. So by having proper testing and maintenance, proper monitoring, and proper business processes. And talking about testing and maintenance, we go into detail about what should be tested, what should be maintained, the frequencies that should happen, and how do we manage that to make sure that we are planning and executing that maintenance at the appropriate time, and that we have a reference to look back on in order to check that everything is being covered. So that's one of the details we go into. And of course, to react rapidly to issues that might occur in our data center, we need a monitoring facility. So we detail what should we be monitoring, what should we be looking at, and how should we be reacting to issues that arise. But key to this course is covering all of the processes that you should have in a data center. And you can see a summary of some of those processes here. But just understanding the headline titles for these processes doesn't tell you everything. In the course, we cover the key issues that should be captured within your process. The easy, simple ways of measuring certain parameters in order to identify where issues have arisen or where they're likely to arise, and how we can address each of those. And as we go through those procedures, we will include specific practical tips on how to improve your computer room. And all of that is produced graphically, as you can see here, along with a detailed explanation of why we try and do these things. For instance, one of the most efficient ways of laying out a data center is in a hot aisle, cold aisle arrangement. But not all equipment takes cold air in the front and blows hot air out the back, and therefore it's difficult to put some of this equipment into that arrangement. But we have different ways of making sure that we can convert that equipment, in this case from a side-to-side cooling unit, into a front-to-back cooling unit to fit in with our hot aisle, cold aisle arrangement and make the whole operation more efficient. And because we are data center consultants, which sets us apart from our competitors in data center training, our courses are based on real examples. So for instance, here you can see some thermal images taken in computer rooms. The dark blue and purple areas are cold, the light yellow and white areas are hot, and an infrared image allows us to see problems very quickly. And the temperature measurements that are taken at the same time also give us an indication of whether a data center is healthy or whether it's been run at the right temperatures for efficiency. At the top here, briefly, you can see it's actually too cold. Many data centers, legacy data centers especially, are run at a temperature much colder than they need to be for modern IT equipment. The one at the bottom is more reasonably set as far as temperature is concerned, and therefore is likely to be more efficient, though use less power for their air conditioning systems. But understanding the limits of where you should set those temperatures is an important criteria that we cover in this training course. Each of these training courses have reinforced learning processes. So for instance, we don't just stand up and tell you about subjects. We have class exercises where you can run through these exercises with your colleagues in the class or with the instructor's assistants where necessary to help you through them in order to make sure you understand the processes that we're talking about and the design calculations that we're talking about. For reference, as I've mentioned before, you have a USB stick with the course content on it, so you can search that at your leisure during the course and after the course. After each module, we have reviews where we ask questions just to make sure that everybody's understood them. And often these will prompt questions from the class to cover a little bit more detail perhaps, or to cover something that we've missed out, or to cover a topic that somebody has a specific interest in. So we try and make these courses as interactive as possible because it's useful for ourselves and also for other students to hear of different people's experiences. At the end of each of these courses there is an online multiple choice exam, again to just reinforce the learning process and to help us to ensure that we have covered everything correctly. If we've covered everything correctly, then everybody will score high marks. If there is a particular topic that we identify people are always getting the question wrong, then we review the course material and we try and make it easier to understand, or we explain it additionally in a different way. And by doing that, we continuously improve our course material. And we've now been doing that for over 10 years, so you can imagine the course material is of a very high standard already. It's standards-based training. The main standards that we focus on are the two leading world standards, the American TIA 942 and the European EN 5600. And we are members and contributors to both of the committees, the American Committee and the European Committee, which developed these standards. The DCE, Data Center Expert qualification, is a European qualifications framework qualification at level 5. So if you undertake DCD and the DCOM course, then you can also gain a level 5 European qualification. The BICSI organization recognizes the DCE training for continuing education credits, and the UK Chartered Institute of Building Services Engineers recognizes DCE as for continuing professional development as well. Remember, if you do the data center design course and the DCOM course, you get data center expert certification. But each of our courses gives you a certificate. So if you just do DCD, you get a certificate. If you just do DCOM, you get a certificate. If you do both, you get 3 certificates, which includes the data center expert certification. And you also get use of our logos. So you get use of the relevant logo, which you might want to put in an email signature in order to provide a reference so that people understand the training and qualification that you have. These courses are instructor-led. We encourage questions, and because we are data center consultants, we invariably know the answer straight away, and often have a real world example that we can quote to explain the answer thoroughly. Our instructors are well qualified. That's me on the right, that's my colleague Barry on the left. We both have Bachelor of Science honours degrees, in Barry's case in communications engineering, in my case in electronic engineering. We both have Masters of Business Administration, and we're both chartered engineers, and we have project management qualifications, data center design qualifications, communications qualifications, and we are accredited tier designers with the Uptime Institute. The bottom line is that compared with our competitors, we've trained thousands of individuals. We've audited personally hundreds of data centers each, and we've carried out designs and peer reviews for designs of data centers across the world. And also, we have improved data center operations for many large IT and co-location companies and organizations running their own data centers. Thank you for listening. I hope you found that interesting. I hope that we will see you on one of our training courses soon. For dates and locations of those training courses, please take a look at our website, www.capitoline.org.